here we're going to multiply some fraction forms, but with polynomials. We call these rational expressions. So the key to doing rational expressions well is factoring and fractions. It's the F and F monster. So you know fractions and you know factoring. So as I simplify this first, trying to get into a multiply, I'm going to use factoring initially. So x minus 2 over, bottom is 4x plus 4, but notice that has a gukuf of 4. So I'm going to write this as 4 times x plus 1, pulling out the common 4 from the 4x and from the 4. Multiplied by, now in the numerator of this second fraction or rational expression, we have x squared plus 3x plus 2. This is a quadratic which can be factored by finding two numbers that multiply together to be 2 and add together to become 3. And those numbers, of course, would be 1 and 2. In class, we do the X method for teaching this in my class, but there's many different ways to learn how to factor quadratics, and any one of them is valid. It'll give us all the same answer. And then in the denominator is just the quantity x minus 1. I intend to do that one in black because it didn't change. Okay, so this is the final answer of the factoring stage. And now, because of our knowledge with fractions, we know we can reduce from top to bottom because all objects are just being multiplied together here. This problem doesn't have a lot of simplification, just the x plus 1 it looks like, because the x minus 2 is different from the x minus 1, and x plus 2 is different from all of these. Yeah, so that's the only reduction we have. And so the final answer will be x minus 2 in the numerator, x plus 2 in the numerator, 4 in the denominator, and x minus 1 in the denominator. I like to leave lots of parentheses around these as opposed to distributing because it is easier for the calculus applications. Okay, well, pause the video and see if you can do this one. This problem has a lot of factoring in it, a lot of different polynomials that can be factored. So, assuming you took a shot here on your own, let's do it together just to make sure we have the right answer. Let's see how close you got. X squared minus 9 is x minus 3 times x plus 3. That one is the famous difference of squares formula, if you wish to do it that way. Denominator, x squared plus 6x plus 9. Well, that's just x plus 3 multiplied by x plus 3. That one's the famous perfect square, trinomial perfect square. This number is twice the completion of the square. Now, x squared plus 4x plus 3, that one's going to need a technique there. And what two numbers multiply to 3 and add to 4? Well, that would be 1 and 3. 1 times 3 is 3, and 1 plus 3 is 4. And finally, in the denominator, we have to keep this one red because we're going to use the same technique here. Two numbers that multiply to negative 3 and add to negative 2. Well, that would be negative 3 and positive 1. Because negative 3 times 1 is negative 3. Negative 3 plus 1 is negative 2. Okay, any good cancellations? Let's go see. X plus 3 and x plus 3 are gone. X plus 1 and x plus 1 are gone. X plus 3 and x plus 3 are gone. And x minus 3 are gone. So the final answer to this problem, I set it up so that it came down to be 1. Everything reduced, and it leaves us with the constant value of 1. Did you get the same answer?